All right, why don't we get going? Welcome everyone to the webinar today on Rightsizing Open Source Software Identification. I'm Heather Meeker of Ombredanne and Myers, and I have with me Philippe. I'm going to butcher your name now.
Which is perfectly fine. As you can hear, with my strong accent, I'm evidently from New Jersey.
Oh, you New Jerseyans. So I'm a partner at Ombredanne and Myers. I think that's an easy explanation, but maybe you can say a couple of words about your role.
So I'm the CTO of nexB. It's a software company, and we help software teams understand what's in their code, especially open source software components. So I'm myself also an open source developer, and I've contributed to many projects over the years and actively participating in the community, as well as developing our own products at nexB.
Great. So today I'm going to kick it off and just talk for a few minutes about open source compliance policies and ease us into the question of how to solve information problems in open source compliance. And then I'm going to hand it over to Philippe, who actually knows what he's talking about when doing that. Okay. And he's going to talk about some more details of some of the solutions that are available to do that. Now, we are live in Silicon Valley, and also we are over the webinar. If you're attending the webinar and you have questions, there is a way to ask questions on the GoToWebinar app, so it's for lack of a better word. So please go ahead and ask questions, and we will try to attend to them during the webinar or at the end. So please feel free to ask questions. Okay, so I'm going to start off. Change this. Here, oh, there it is. Okay, not moving. Okay, the space bar. Okay, so today we are going to do a brief agenda. We're going to talk about the key elements for a policy for use of open source software. We're going to talk about the process of open source identification, why, what, and how, a survey of open source and commercial tools for open source identification, and right-sizing the open source identification process and tools. You know, I'll just start out by saying that people ask me all the time about these practical questions and how they can go about identifying the open source software that they're using and what tools are available. So this webinar is an effort to provide some information about that. Okay, so first, I'm going to talk about why companies have open source policies. I think today most large companies have written open source policies. That's been a change over the last 10 to 15 years. Of course, it's always nice if you actually follow your written open source policies, but companies have open source policies for a variety of reasons, and this slide is a little bit of a graphical explanation of why and what is in the policies. So you'll see that the tactical end is knowing what open source software you're actually using, and then sort of in the middle is setting policy for doing transactions that involve open source, and then more on the strategy end is managing unintended consequences for IP. So this roughly tracks the life cycle of a company in the open source world. Most companies start by using third-party open source software, and so they have to make sure that they're compliant with the licenses that apply to that software. That's a tactical question. And then as they start to do business in an environment with open source software, they have to negotiate terms with other companies, either on the buy side or the sell side, that mostly have to do, again, with open source compliance. So that is more on the tactical side. And then as they move through their life cycle, they get to the point where they're contributing to third-party open source projects or actually releasing open source code on their own. And that moves more into the strategic area. So this is a bit of a life cycle of the company and the kinds of issues that I talk to clients about every day, and also what tends to be in open source policies. But today we're really going to focus on tactics and not strategy. So we're going to be talking specifically about how you deal with the information problems involved in figuring out what open source you're using and actually complying with the licenses. By the way, one of the reasons why there's an information problem dealing with open source is that open source circumvents a lot of business processes just because of its nature. So open source software licenses don't require any click to accept. They don't require you to sign anything to say you accept them. The theory is that unless you accept them, you won't have the rights that are granted in them. So what that means is people start using open source software in an organization without going through a procurement process. If you want, say, copies of Microsoft Office, you have to go and get a license for them, and that means you need to sign a contract, go through a procurement process, cut a check for the license, and that kind of process, businesses are well set up to go through that kind of process. What that means is somebody reviews the license terms, a lawyer or other people in procurement, and if they agree, then they cut the check for the software. Open source doesn't work like that. It's free of charge to license. It also doesn't require you to sign on the dotted line, and so it circumvents the process of looking at the terms and figuring out whether the company is going to use the software agrees with the terms. So that's where the information problem comes from. When open source started to become popular, companies were simply not set up to track it. And tracking it can be, it's not an intellectually difficult task, but it's a pragmatically difficult task. And that's why we're sitting here talking about this subject today. Most companies use so much open source software today that they try to automate the process of tracking this information one way or another, and that's a good idea. And tools have started to develop to help companies to do that. But I think it's probably fair to say that we're still, almost at the infancy of developing those tools. There are various tools to do various kinds of things like figure out what open source you're using, create notice files, and so forth, make decisions within the organization, route requests to use open source software within the organization, and all of those things are in the process of being automated. So people who are managing this process in the trenches can find the array of tools that exist out there confusing. And rightly so, because there are new ones fairly frequently, and they're not sure which ones are going to work for them in their organization. Also, once you've gathered the information, you need to apply that information to the policy that the company has put in place about open source. And the substance of that policy mostly has to do with figuring out what open source you can use based on different licenses. So now I'm going to talk a little bit about what the substance of most policies is. This can vary from company to company really quite a bit, depending on what business they're in and what they're doing with software. But this just gives you a general global idea of what companies put in their policies in terms of substance, not in terms of process. So in order to understand how to assess whether an open source license works in a particular situation for a company, you have to know what the company is doing with the software and what the license is, and then of course you can compare the two. So in companies today, there are several very important use cases for open source software. there are use cases that involve simply using the software internally, meaning, for instance, using it as a development tool, or maybe even just using it for back-end processing. And then there are use cases that involve actually putting the software into a product and distributing it or making it publicly available. I gave some examples here of sort of typical things that come up for a lot of companies in these different use cases. So FFmpeg is a utility that processes MPEG files. That is often put in products because it's something that, if you have an AV product, you're going to need something to encode and decode files according to various audio-visual protocols. That is software you would put in a product and distribute. Git, which by the way is the basis of GitHub, is a source code collaboration tool, and a lot of companies might use that to perform development. They don't usually put it in their products. However, it is involved in development. A really sort of back-end internal business use case would be something like MongoDB, which is a database. It does get put in products sometimes, but for the most part, people are using it behind their firewall to do things like store information about their business or store information in connection with their products. So these are very different use cases that have different risk profiles. Now, most companies apply their policy and they triage by license. So they say, if the open source software is under this kind of license, you can use it for this kind of use case. Or if the open source software is under this other license, you can use it for these other use cases with certain conditions. Some companies actually get more granular and they require internal approvals project by project or use by use. But I would say that about 90% of the companies triage by license. And when I say that, here's what I mean. This is an example of the guts of an open source policy when it's applying to compliance and use of third-party open source code. And I know the print is pretty small here, but there's a stop, a go, and a caution. So go means if the software is under this license, do anything you want with it. Caution means if software is under these licenses, you can use it in certain use cases. And stop means we're usually not going to use code under this license. Now, every lawyer knows that there's kind of no such thing as stop, because if you go to the legal department, you say, no, I really want to use this code, and this is a special use case, and it's really important, maybe they'll say okay. But the messaging here is, if the software is under these licenses, then we're probably not going to approve if you ask us. So you might want to think again about, wasting everybody's time asking us about it. I realize this is small print and hard to read, but the Go licenses are mostly what we call permissive licenses, or notice only, or academic licenses, or non-viral licenses, like BSD, MIT, and Apache. The caution licenses are most of the copyleft licenses, like GPL, LGPL, Mozilla, Cuddle, Eclipse. And the stop licenses, you'll see on that list is GPL3. That's a little bit controversial, but this is a somewhat conservative policy. Affero GPL, and a few others that have terms that tend to not work well with the processes that most people have in place. I have put on the side in probably equally illegible writing that this is actually in my book, which, if anyone can see this, is here. It's called Open Source for Business. It got released this year. And it's available on Amazon, and only Amazon because I published it myself. But it has a bunch of examples, and this is one of the things in the example. So if for some reason you cannot access this book, email me, and I'm happy to provide you with this information. So that, if we can get it to go forward.
There you go.
Okay, so I'm going to now turn it over to Philippe. This was just a background to lay the context for what we're talking about. And now Philippe is going to give you a lot of useful information about how to think about tools to track open source software.
Yes, thank you. So I hope that you all agree that ignorance is not bliss, and you need to be able to identify and know what are the open source and generally any kind of third-party software that you may include in your product or applications. So why, of course, there's a legal angle. There's also an interesting business angle, which is when you reuse third-party code, it may have bugs, security vulnerabilities, quality attributes that you want to match with the level of expectations you have. All these are good reasons to know where the software comes from, what's the license. And so the goal of that identification is creating some reasonable inventory, listing any third-party software origin license. And the last mile is compliance. And when it comes to open source, it's essentially attribution, providing credit notices, and in some case, redistribution of the source code, primarily for what we call copyleft licenses. Now, OSS identification, again, for creating this inventory, we talked about origin or provenance differently. That's the primary use case, primary thrust, determining where a piece of software comes from. You could ask, why would you want to know that? Shouldn't be known up front ahead of time. Well, as Heather was saying, it's very easy to provision software on the web. In a few clicks, you can download and use it. Modern applications and software products may reuse thousands, literally thousands of these third-party open source components. It's hard to keep track of these, and they're evolving continuously. That's why you want to do that. The other thing that's important is understanding how things are used. You may use it internally, use it as a development tool, or you may use it as part of an application. And origin, license, and usage are the three primary domains. So on how you actually go to perform this identification, there's a few techniques. What we call scanning is really about finding evidence in the code. You have a copyright statement, you have a license notice. This is a strong indication that what you see is effectively what it is. It's not always 100% the case, but that's a very strong indication. And that's what we call scanning. It's looking inside the code for clues about origin and license, explicit as they exist in the code. The second one is matching. And matching is different in the sense that you'll be looking at similarities between your code and a large index of open source code. And if the code is similar, if they look alike, they may share the same origin. Important word here is may. It's not always 100% true. And there's a third area which we call tracing. It's not the purpose today. Tracing is about determining how things are used. Is a piece of code that I use in development part of my redistributed product? That's where you would use tracing. It's an important area because most of the obligations of open source licenses are triggered by actual redistribution. Now, the overall process is using these tools and techniques, and unfortunately, we wish it would be automated and certain 100% of the time. You need to have human and expert review. Before we go further into detailing the techniques, I'd like to do a quick demonstration of this open source tool called ScanCode, which is a project sponsored by nexB. And just to see, so you can understand what it means to scan, and see that it's not a very complicated process. This is an open source tool, so that's free and open source software to scan free and open source software. So it has a nice recursive twist to it. And this is the output. of pointing the tool to a directory of software. We have a few quirks with Internet Explorer. I hope there's not too many flashes on the screen. Nevertheless, on the left-hand side, you see a file tree, which is a set of files that were in the directory you scanned. On the right-hand side, you see the results. And what it tells you is that a certain license or copyright was detected in the code. Eventually, very precisely, where in the code, at what line. You can access a few extra informations, which are public information that we collect on licenses and the essential requirements of license. The key takeaway here is that it gives you easy and actionable information that you can use to make a determination later on whether this actually matches your policy, and you can search and slice dice. It's free and open source tool. It's available on GitHub. And that's the kind of tool that you want to use as part of your arsenal of identification. So let's get back to the presentation now. So how does scanning work? So as I said earlier on, when we talk about scanning, we're looking about evidence. That means things that are found explicitly in the code. An example could be a copyright notice at the top of the source file. It could be a license file, which could be at the top of a GitHub repository or buried down somewhere further down. It could be a license notice in a source code file again. It could be in the context of software libraries, what we call packages. There's a lot of these packages and things you may have heard about, like Java jars, Ruby gems. On Red Hat, you have what's called RPM, the Red Hat Package Manager. These are formats of archive to bundle together as a library several open source files together. And these libraries and package libraries usually come also with some metadata, which provide you some clues about where they're from, who wrote this. In some case, you even have a copyright notice. In some case, we wish it would be always there. You have some license information. But they're important information because whoever actually created this package went through the trouble of providing some of this data, and you don't want to ignore that. Beyond that, information such as an email, a URL, name of a person, an author, all these are good clues about the fact that there's somebody that was involved with the production of this software, and maybe a clue about its original license. And what you look at is you look at that not only in text file, but also in binaries. And there's ways to actually introspect these binaries, extract them, extract strings and other information to look at not only the source code, but also binaries. A lot of the software these days may be consumed by software teams as pre-built binaries. In the world of Java, for instance, most of the Java libraries are reused pre-compiled as binaries, as is, in most cases. So it's important to be able to introspect and analyze the binaries. So in terms of techniques, generally speaking, the basic techniques in all this scanning is about doing some kind of pattern matching. But each of the type of information you look for requires some specific approach. For instance, copyright. You would think copyright statement is something that should be pretty simple. Now, you wouldn't imagine the different ways people can write the copyright notice. There's hundreds of these. And they put year range, and they put a copyright sign or a C sign before and after a copyright word. They put one or more person. They put all rights reserved or not at the end. In the end, it's rarely enough something which requires several hundred lines of code to be able to build a syntax and grammar that's able to accurately recognize all the various forms of copyright statement that exist in the wild. When it comes to detecting licenses, there's various approaches. One is to use a lot of small patterns which you build over the years, which are all the small keywords that are the telltale of license. That's one approach. Another approach, which is the one we use in ScanCode, is to build an index, which is like a Google-like search index, if you want, except it has a different purpose. It has all the license text you can find, all the license notice and mention and statements that you collect, and you put that in an index. So the index is relatively small. You're talking about 5,000, 10,000 items and documents that you index. And you query using your code base. So now the query, instead of being a few keywords like you would do in a Google search, here the query may be gigabytes of code. So instead of having a very large index and a very small query, here you have a reasonably small query. You're talking about megabyte size queries, megabyte size indexes, and eventually large gigabyte size queries. The other thing is you want to have a high level of confidence that when you find a license, it's actually what it is. So you're not looking for approximate matching, and you will see when you do a search on Google, well, sometimes the results you want is actually buried at the bottom of the first page or on the third page, and you wish it were at the top. This is not acceptable when you actually detect licenses. You want to be absolutely sure that what's being found is effectively exactly that. And there's ways also to do approximate matches, but you want really to promote and ensure that you do exact matches first. Then when it comes to library and package metadata, you have very specific parsers and analyzers that are able to recognize how these metadata are expressed in Node package manager format, in RPM, in Java jars, in Python wheels, in Ruby gems, and so on. And between, quote, more mundanes, typically what's called regular expressions, a form of pattern matching, to be able to capture and collect things like emails, URLs, and authors, and person names, which is a bit more involved, be able to recognize out of many words whether the sequence of words actually represents a person is a bit more complex, of course. So this is the key techniques used for scanning. And if we come back for a second to what we are looking at in terms of results, this is what it gives you here, looking at examples of copyrights and license. So it's pretty accurate in terms of telling you that from line 1 to line 502 of this license file, you have text of the LGPL21 license. And at line 104, you have copyright. So this essential information that allows you to very quickly conclude whether, first, license-wise, this is complying with your policy or not, and second, who is actually the provider, and next step would be, how do you comply? Well, you know the author, you know the license, you know the copyright, so you have enough information then to actually produce any kind of credits and eventual retribution if, in this case, this is an LGPL license. So let's go to another technique that I talked about earlier, which is matching. So matching is similar to do a very large scale file comparison. So similar to redlining or blacklining two legal documents, except on the one end, you have several thousands of your documents, which are your code files. And on the other end, you have eventually millions, or sometimes billions, of open source code files. And you're trying to find similarities between the two. And the thrust there is to say, if there are two files which are similar, they may share the same origin. It's important to say may, because there are many cases where you can have files which are very similar, and they have absolutely no origin in common. As an example, if you as a developer use Microsoft Visual Studio, which is a very common tool for editing and writing code in a commercial setting, and GPL developer who provides GPL software use this same tool, the tool will generate some boilerplate code in both cases, which will be the same. Doesn't mean that your code is GPL because it has a similarity with some GPL code. It just happens that you were both using the same tools. And that creates, of course, quite a bit of a monkey wrench in the equation, which is being able to identify bits of code that are generated or may share similarities but are completely unrelated, makes this difficult thing. In terms of matching, it can be done at multiple levels. You can look at whole libraries or files or snippets. And the deeper you go, the more likely you'll have more review to do because you'll have more matches, more possible false matches. To give you an idea, if you think about a Linux kernel, so if any of you has an Android phone, you effectively have a Linux kernel running in that Android phone. An Android Linux kernel is about 50,000 files in source code, about 14 million lines of code. If you look at this as one aggregate, it's pretty straightforward to understand. It has an overarching license with GPL with some form of exception for user space usage. There's a few ancillary licenses. It has thousands of different copyrights, but it's overall Linus Torvalds and others, which are the copyright holders. If you treat that as 50,000 files, you have a whole new problem on your hands in terms of review and analysis. So understanding that you can do this kind of matching and scanning at a whole aggregate or going down to the file or snippet level is important because the amount of work to review and come to any kind of effective, usable conclusion depends a lot on what you're looking at. At the technical level, the techniques used for doing this large-scale comparison use what we call fingerprints. So it's a small string. Instead of comparing the whole file side by side, if you have gigabytes of code on one end and terabytes of code on the other end, and you do a pairwise exhaustive comparison, in most cases, using all the data clusters and data centers from Google, DNSA, and Facebook would not be enough to complete this in several years. So practically, as a proxy, there are mathematical constructions that we call fingerprints, which are small strings that you can use to effectively do the comparison on much smaller size as a proxy, and then do eventually more exhaustive comparison in the second step. So once you've done this matching and scanning, I shall insist that, unfortunately, as much as we'd like to get this to be conclusive and determinative and authoritative right away, you need to have some review on this. And in fact, the level of review is slightly, that's needed is slightly related to the type of techniques you use. When you think about scanning, which is about evidence, evidence is an evidence, right? It's what it is. You have much less review needed about evidence information than about matching and similarity, which will require a lot of interpretation. And so that's something that's important. And as Heather was saying also, you want to make sure that you balance the risk and effort. And we'll come back to that in a second. The last mile is about finding issues, right? Is the components and the software, open source software I've identified, is it any kind of issue? And it's in the eye of the beholder. It's a matter of policy. If I am an open source software developer and my project is GPL licensed, obviously my policy will be I don't want proprietary code in there. So proprietary code would be an issue. GPL licensed code probably would not. In contrast, if I'm working on a commercial software that's an embedded device, I may have specific constraints about reusing GPL in some context. But if I'm doing Android-based device, I will reuse GPL, and I shall approve it, of course, in my policy. Otherwise, I wouldn't be able to build a product at all. So it's really a matter of context, and there's no one single solution in terms of what is an issue. And even if you have a policy and you find an issue, it may not be an issue, or there may be exceptions. There are, though, a few essential things which are always issues, which is non-compliance with the license terms. And they boil down to two essential things. One, which is producing some credits. So I gave you software for free, which is open source. Credit me for my work. And there's many different ways this is expressed in different licenses, but it really boils down to that. And the second one, in some case, redistribute the software source code for the component that you use, including any modification that you made. And it's not hard. When it comes to resolving issues, when you have some usage pattern that may be in violations of your compliance policy, then there's really many ways to think about it. But there's, again, not one size fits all. The key thing is being able to comply with the essential of the license is an easy one. Discussing with the legal counsel to ensure that the remediations actions that you do in more complex case involving certain combination of proprietary and open source code is something that's taken on a case-by-case basis. Now, let's talk a bit about how we can effectively right size, given this array of tools we have for scanning and matching. And given the different set of risks and policies that we may have designed, how we can right size the efforts, selecting tools to identify open source components, and right size the efforts and processes you want to apply. There's really two axes. One is a matter of scope, which is I have products and applications, and nowadays as a software company, nowadays any company is somehow a software company. You may be doing industrial product that embeds software, but even if you're not an industrial company that embeds software in its product, you may have a website. And a website is software today. It's no longer a set of static pages. You may be publishing apps on app stores. And even though you don't think at all of yourself as a software company, you have not only internal usage of software internally for applications, but in most cases also you actually effectively produce and redistribute software that may be used outside. And this scope is really about determining what are the bits of software that I use or redistribute, which are the most exposed to a larger audience. And the second axis is determining how critical it is to my business. Right? An internal tool may be pretty limited in terms of exposure. If you put these two on a matrix, you have a nice Gartner-like or Gartner-like quadrants. Actually, I think it was the Boston Consulting Group that initially came with this quadrants approach. But if you plot the exposure of a piece of software or application on the one end, in terms of how many people does it reach and use it, and how critical is it to your business on the other end, you may decide that some areas require less emphasis on the license or the provenance or the usage. If you look in the upper right corner, knowing accurately the license, provenance, usage for critical business software and highly exposed software is essential. In the lower left corner, if you think about maybe using internal desktop suites, getting all this information is less important. In some case, understanding the provenance of the license may be more important. For instance, if you think about IT security domains, making sure the software is fully vetted in terms of bugs and security vulnerabilities may be more important, relatively speaking, than license. Of course, you always want to make sure that you can use the license, but you may not want to always have a very accurate determination of all the licensing terms as long as you know what they are at a high level. So it's a matter of depth. The other axis is when you think about software component reuse, it's about depth. You may reuse a whole product. So we were talking about the Linux kernel, 15 million lines of code. That's significant, right? That's really material. At the bottom of the hierarchy, reusing 10 lines of code is not much. It's small. Doesn't mean it's not important, but it's small. I think that Google and Oracle have been arguing for years about 10 lines of code may be reused from Java into Android. So there are people that are arguing and going to code for 10 lines of code. So it's not unimportant. But from a business perspective, the value you derive from 10 lines of code versus from 10 million lines of code is vastly different. The risk also attached and the effort of removing 10 lines of code versus removing 15 million lines of code is vastly different. Interestingly enough, the effort to identify whole products and whole libraries is pretty straightforward, and that's something you can do with scanning without having complex matching machineries. Whereas looking deep inside file and snippets, something that requires much more involved process in terms of tools, as well in terms of human review. And roughly what we see is that the cost of looking at products and libraries thoroughly versus looking at file and snippets is roughly half and half. In some cases, maybe 20-80. And it's important to understand that if you spend a lot of your money and dollars on things which have lower value and lower risk, you're probably doing something wrong at some level, at least from a business perspective. So again, it's important to ensure that in identifying open source components, you look first at the bigger ones, where you derive the most value and you have the highest risks, rather than spending a lot of your money and efforts on things which would be lower value and lower risk. It's common sense, but it's important, and it's not widespread common sense, unfortunately, in this business. So last word, which is about how you go about effectively doing this identification. The thing is that with the advent of free and open source tools to scan free and open source software, you have now the possibility to more efficiently distribute this identification and have product software development team be able to use this tool, include them in their build process, and perform due diligence on a more continuing basis, being able to more efficiently check for the origin license of component at the time they will reuse it, and provide more data and more information when things may not be exactly in compliance with the policies, for a legal team, an open source review team to have some meat to work with, as opposed to just, I want to reuse this, tell me if it's okay, and you don't have any information about that. So that's important, and that's really enabled by this, the emergence of this open source tool to which we are participating. Now let's look now a bit at some of the tools available for identification. And let's look first at the open source tools. The Linux Foundation has a resource page that you can visit, which provides some pointers. The grandfather of all the tools in that space is a tool called Photology. It's originally provided and sponsored by HP. It's now moving to the Linux Foundation.
That's scanning only?
Its primary purpose is scanning. So it's similar to scan code, slightly different approaches, but essentially the same. It's able to scan for licenses and copyrights and a few other extra information, and provide you a way to collect evidence from code base. We talked about scan code. There's another one called Meeker and a few lesser ones which exist. Ninka is being integrated in Fossology, but it's another approach to detecting licenses. So just to explain some of the differences there, Fossology looks at licenses primarily using patterns, small patterns of keywords which are markers for the presence of a license. Lots of them, like several, 5,000–6,000 of them. Ninka, which is another license scanner, is using phrases, sentences, trying to isolate sentences, and based on an index of sentences of license, find, is this a BSD2 clause, is the BSD with 3 clause or 4 clause. In contrast, what ScanCode does is, again, building a special search engine, putting a lot of license data in it, and trying to find alignments between your code, text, and the license text. They end up providing the similar kind of results. It's the complexity is how much knowledge of the domain you need to have to evolve the scanning capabilities. I tend to think at a purely data-driven approach, where you can throw more data at it and get more results, and tends to be simpler and easier to maintain in the long run. So that's why we use in ScanCode. Now, interesting point, that's what Heather was telling too, is most of these open source tools today are focusing on scanning. That means looking at evidence. In contrast, if we look at some of the commercial tools available, their primary concern is matching, though Palamida and some of them do also include some of these open source tools as part of their approach. But most of these tools, Black Duck, Palamida, Protectcode, are concerned with scanning, not so much with scanning, but with matching. And they're concerned mostly with scanning, matching bottom-up, that means looking at files and snippets, which is very useful in some cases when you have the need to do a deep analysis of a code base. But it's also a costly approach because you need to do an extensive review. Again, when you're looking at matching, you have a lot of potential matches to review, many of them being false matches. It's difficult to understand when a common piece of code has been reused in many other open source projects. Think about Linux. Linux reuses code from many other projects, is being reused in many projects, and then code of this project ends up in commercial products. And trying to understand who wrote the code when, what is the real original license, is really difficult with matching.
White source only works on Java, is that right? Or I thought it had limited.
I think white source scanning is, so it's using Ninka. When it comes to matching, they seem to be primarily focused on Java. But I'm not entirely privy on how they work. They seem to be mostly looking at exact component match on Java, as far as I know.
Yeah, I think they don't include low-level languages because it's too difficult.
Well,
I don't know. That's what I had heard several years ago.
Yeah, I wouldn't know exactly what's the status today, but the thing about matching is it depends how you do it. But normally there's not much specifics about a language. What you want to do for matching is look at source, collect fingerprints, and build a massive index of these fingerprints, and then try to be as efficient as possible to perform the matching so it doesn't take years to match, and provide as much help as possible to review these matches, because you may have, in some cases, tens of thousands of matches for one file, and therefore the review becomes a much more involved process. So all these tools are somewhat similar again. It's not a question of should I use this tool or this tool, is what are the techniques and depths that make sense? I think that in all cases, you should do scanning, especially with free and open source tools. There's no reason and no excuse for any user of open source software that's serious about complying and crediting the authors of the code that they're reusing, not to use these scanning tools. When it comes to matching, this should be done on a case-by-case basis, based on the exposure and the level of business criticality of a piece of software. A few other compliance resources. The Linux Foundation. So disclosures, we're a member of the Linux Foundation, and we're co-founders of the software package data exchange effort there. Provides a good set of information as a starting point. OpenSource.org is the place where you find many of the original open source licenses, as well as this SPDX website. So SPDX is an effort where you have many software producers banding together, trying to define a format to hopefully exchange efficiently information about provenance and license, so that someday, hopefully, scanning and matching would be a non-issue. TLDR Legal is a website that's more of a social angle on licenses, where people discuss about the different licenses, term of services, and try to collaboratively distill the essence of these terms, so they're easier to consume from a developer perspective. And we, nexB, provide also Deja Code, including a public resource which provides a lot of reference information on licenses with some, I wouldn't say interpretation, but some classification of the different categories of licenses and the type of terms as we can see it. This is not legal advice. So that's pretty much it. I think at this stage we're gonna open questions. So let me try to.
On the webinar?
Yes. So I see somebody raised a hand.
I understand that when I was giving the introduction at the beginning, I was on mute for a serious portion of that, which probably improved the presentation. But you weren't. You weren't. No, this
okay.
Is what I understand. So if anyone wants to, I think we've recorded this today, so if anyone wants to catch up on that, there'd be an opportunity to do that.
Okay, so how do we go about questions?
Let's see who. That's a good question. There's a question. There we go.
Okay.
This is so small, I can hardly read it. Oh. I can't hear. There's a lot of I can't hear on here.
Yeah, that was from the first.
Okay.
Okay.
So to all of you who said I can't hear, sorry about that technical glitch, but there is a recording that you can refer to. And I think it was only for the part that I was doing. Anybody have any substantive questions on the webinar?
Or in the room. Yeah.
Or in the room, of course.
I have a few, actually, I'll start with. What is your thoughts on manual compliance? It says on a product base, version by version, release by release, we implement a self-reporting. So that's going to take away the need for scanning and possibly matching in the long run.
Yeah, so that's the way most companies start. It usually consists of an Excel spreadsheet where somebody keeps records about what open source they're using. And I would say that is an absolute minimum baseline. The problem with that, of course, is that it's usually pretty inaccurate. And when I say pretty inaccurate, the self-reports I've seen, they're sometimes like 90% inaccurate. So the problem is that they're not reliable. Of course, the more educated the developers are about licensing issues, the better they will do. Self-reporting. Self-reporting is key. You cannot just rely on back-end matching and scanning, because self-reporting tells you information that is actually, it has kind of ancillary importance when you're doing real-world tasks like negotiating about reps and warranties for open source and understanding how the open source is used. And you can speak to this if you disagree or have something to add, but one of the limitations of any kind of scanning or matching tool is that it's looking at the software as text, more or less. And what the self-reporting will tell you is details about how the software is being used. And that is key for compliance with licenses like GPL and LGPL. So you have to get that kind of information, like which product is this in? If you have 12 products, which one is it in? Is that product distributed or not? You know, that kind of information is like meta information that is extremely important to compliance analysis, but the scanning and matching tools are a little more granular looking. They're doing basically like a bill of materials. The self-reporting tells you a lot more information. Also, I'll stop talking in a moment. When you're on the buy side and you get a self-report, the way the self-report works tells you tells you a lot about the sophistication of the seller, and that's actually a key indicator when you're negotiating deals. Because if you get a self-report that is obviously wrong, and then you know something about the seller, which is that they don't have the internal controls they should have. And so my reaction then will be, okay, this didn't work, so now we have to up the level, and we cannot rely on the self-report. So you want to add anything to that?
Yes, so to add to what Heather was doing, I think to be able to accurately determine what is effectively used, so it's other techniques that are called tracing and disclosures from the team. But in some ways, if you don't do this determination, it's like you were looking for the recipe to do a cake, but you end up with a long list of everything that was in your pantry in terms of ingredients.
Yeah, exactly.
So
that's a very good analogy.
The disclosures and the self-report will tell you how you do the cake, or really which of all these ingredients are really used to do the cake, or are you making a cake or something else. There's ways to supplement that with tracing. It's another set of tools and techniques, and you can think about two things. First is you have a bunch of binaries which are being distributed in a bunch of source code, and you're trying to establish relationship. Which source code goes into which binary or not, if it's not used at all. And you can do that by doing some static analysis of the binary and source, or you can dynamically trace a build to figure out, oh, I've watched how the software was being compiled and built, so I know this part goes here, this part goes there. And that's a way to get a bit of the what is really the recipe and what is really used. So, but to Heather's point, you need both. You always will need this self-report. And from experience, it's really a very strong indication of the level of sophistication, maturity, and understanding of open source that a software team has. When you see somebody tells you, well, give me the list of your software, and says, well, I use this, it's free, I use this, it's free. And that's a bit light in terms of details about what the license is.
There's something that I'll mention just for those who are not, have not been involved in software development. When you develop software, you have this sandbox that you're working in, development environment, and you might have a lot of code in there that you might use. You might not use all of it. So it's kind of like if you have you're a lawyer and you have a forms file, you have hundreds of forms in there, but you only choose to use one. It's a problem to then go and assume that you're using all of it, because then you're going to waste a ton of time, reviewing a bunch of stuff you're not using at all. So the self-report, and also, most companies have this process where if a developer wants to use open source software, they'll like fill out a little request. That information is really important because that tells you what you actually have to be looking at with these other tools. And there is a huge amount of stuff that never gets into the product build. Sometimes it's, well, we downloaded this because we wanted to use it to test, but then after we stopped testing, we never used it again, but we never took it out of our development environment, because why should we take it out? There's no downside to leaving it in there. And then somebody decides we're going to do a black duck thing, and they hand over the entire development environment to black duck, and it costs a fortune and is, scanning a lot of code that isn't actually in the product. So that's key information, and that's actually one of the common breakdowns in this whole process is you have to know what's in the product, what is in what product, and what products are being distributed. So that's
And so we have a question that's actually very much related to that. Heather's question from Sami. He says, I am slightly surprised that the focus is on scanning and matching, but my view is that you will need the actual use case to determine the associated risks.
That's 100% true. That different use cases have wildly different risks. At the beginning, and I realize some people didn't hear me say this, but there are some use cases, like say you were using software in your business to run your payroll system. That is like incredibly low risk. You're just using it. You're not distributing it. It's not part of your product or anything. And then on the other end, you might have software that's actually in your product. That's the stuff that is the most, potentially risky. And then there's some stuff in the middle that's like development tools, which can kind of cross between those two categories. But unless you know the use case, what you will have if you do scanning and matching is a lot of information and no answers. There's a difference between information and answers, and the tools are tools to get information mostly. To get answers, you actually have to think about what you're doing and get some of this ancillary information.
Yeah. So, practically when we do scan a large commercial product code base, you find test code, which is used in development, and lots of it. The more practices of software developer mature, the more they write tests. So you have huge amount of test code that's used only to test that the software works. It's not part of the end product or end application. You see that code, prototypes, things that were used in the past that have been left in the code tree and no longer used. And very often when you do this kind of prototyping, you experiment with various open source libraries. That doesn't mean you end up using them. You've just been doing experimentation. You see sometimes large repositories of open source libraries, which are kept to ensure that they're always available, even if the project upstreams were to disappear. But you may have 1,000 libraries in this repository, which have been used over the years in the various release of a product or application. But today, maybe only 10 or 20 of the latest versions are used. So you could scan and analyze and match the 1,000 versions when you really care about, in most cases, what's current, which may be 20 of them. And reviewing 1,000 versus 20 is obviously a different amount of work. The converse is interesting, is that you may have in your distributed product code that exists nowhere in your development environment. That is, you were to scan, if you scan your source code, you will not find anything. But when you look at the binaries, the code is there. And what happens is today when you build software using Ruby, Python, JavaScript, Java, you rely on external repositories of software components. They're called Maven, Ruby Gems, PyPy for Python, the NPM registry for Node.js and JavaScript. And what you have in development is a small file saying, I use foo version 12, bar version 10. A small file that just said that. When you actually build a software, your tool goes to the external public component repository, fetches foo12, bar 13, plus looks at what bar 13 requires as other dependent components. So it fetches A12, C42. You end up very quickly having hundreds of components that may exist in the as deployed, as built binary of your product that don't exist anywhere in the development code base. That's another twist. That's why it's probably very important use case. Beyond use case is looking and eventually scanning and matching not only the source code, but also the final product. It's only by eventually tracing between the two that you can not only focus on the things which are important. I mean, don't worry about the thousands of components that may exist which are not used on the one end, and also ensuring that you still take into account the things that only exist in your code tree used in development, but exist in the final build product because they were provisioned from the web at build time. So I hope it doesn't become too technical there. But
no, that's a really, I think, a really great point. Yeah. Well, I see we're out of time.
We have another question.
One more question. Maybe we'll do one more.
Yeah. So the question is, for software developers, what level of resistance can they expect if they link their warranty obligations rate non-use of open source software to scan reports?
Repeat that again.
So for software developers, what level of resistance can you expect if they link their warranty obligations about non-use of open source software to scan reports?
Well, it's a bit of a complicated question, but maybe I'll answer a slightly different question.
And I'll try to answer another one after that.
Okay. When you're offering support, it makes a lot of sense that you want to know what you're supporting. So the kinds of restrictions, and this gets a little bit technical on the legal side, but if you're making an obligation to someone to provide support in exchange for money, that's a services contract, and you can make that dependent on whatever criteria you want. And usually one of those criteria is going to be that you won't support stuff that other people have changed. So that is a baseline that, you know, is just a commercial expectation. It is possible to write those kinds of contracts in ways that actually violate open source licenses. I don't suggest that anyone do that, but it's really important to distinguish between an obligation for support and license terms. The open source licenses like GPL, you cannot actually vary their terms. So if you try to say, I'll give you support, but you have to promise not to change your GPL software, that's actually can be a violation of the license. But you can say, I'll give you support, but I won't support changed software. That sounds slightly different, but it's completely different from a legal perspective.
Okay, so Samir, let me give you a different answer to a different question than the one you've asked. But so you were asking about how warranty obligations for a software developer could eventually be linked to a scan report, especially a warranty of not using open source software.
Oh, so, I see. Okay, I misunderstood.
I'll let you answer that too, but I think that practically today, if you have a customer or client from a legal perspective, or if you're a software team, not using open source software would be probably a mistake. It's not only a mistake, but it's unlikely to be even practical possible. I don't think out of the several hundreds of large commercial products that have been involved in scanning and auditing, there's been probably one or two maybe out of these 500s, which had absolutely no open source or third-party code inside. And frankly, these were fairly small and very specialized domains with very specific history. Not reusing open source software today is probably a mistake. There's a lot of excellent software that's community developed, community proofed, community debugged, and in some cases that's the only piece of software that will be available to do a certain job. So if you're not using open source software, and if you warrant, for instance, or expect a third-party software contractor to develop purely original software and not reuse any open source software, it's probably a business mistake. You're probably wasting a lot of money when having them reuse open source would be the right thing. Now, the answer to your question is you obviously want to make sure you know what they reuse, what we license, and how this would comply with your policy.
And if the warrant, so I was talking about performance warranties. If the warranties are more like IP warranties, most of the ones, and this is just for the IP lawyers, most of the ones that are written in such a way that say you can't use open source software, they're just not written correctly. You can write them in a way that's correct, that gets at the business concern that you have, but I see a lot of them that are written in, in a broadly overwritten, and that is how I would describe something that says you can't use open source software. So, all right, well, thank you very much. It was a pleasure presenting with you. I hope those on the webinar enjoyed it. If you have questions, don't hesitate to contact either of us, and we would be happy to answer any questions you have. Thanks very much. And by the way, CLE credit, there was an email address that you can email if you have questions about CLE credit. Thanks, everybody.